The eruption of Mount St. Helens on May 18, 1980, stands as one of the most significant geological events in U.S. history. Can you elaborate on the immediate impact of this eruption, both locally and globally?
Certainly, the eruption released energy equivalent to 24 megatons of thermal energy, leveling nearly 230 square miles of forest. The ash cloud circled the globe within 2 weeks. An anecdote from the time describes local residents in Spokane using snow shovels to clear ash from their driveways as if it were winter snow.
Astonishing. While the raw power of the eruption was undeniable, some argue that such events are too rare to significantly influence long-term ecological studies. How do you respond to that skepticism?
It's true that volcanic eruptions of this magnitude are infrequent. However, they offer unique opportunities to observe ecological succession. Post-eruption studies sparked new ecological theories. Take, for instance, the rapid return of species like the lupin, which paved the way for diverse plant communities within a decade.
So looking ahead, how can these lessons in rapid ecological recovery influence today's conservation strategies?
Looking forward, integrating these insights could enhance habitat restoration efforts worldwide. For example, adopting a more dynamic approach that allows for natural recovery processes rather than overly managed interventions can lead to more resilient ecosystems.
The post-eruption landscape provided rare insights into resilience. What lessons have we learned about adaptability and survival in extreme environments?
The ability of certain species to adapt quickly was surprising. Small mammals like the pocket gopher played a crucial role in soil turnover, fostering plant growth. Their activity demonstrates nature's inherent adaptability. This adaptability contrasts sharply with the idea that ecosystems need human intervention to regenerate.
Some suggest that left alone, nature always finds a way, yet human interference is often unavoidable. How do you reconcile these perspectives in conservation efforts today?
Indeed, the dilemma lies in balancing intervention with natural processes. Unchecked, invasive species might dominate, resulting in decreased biodiversity. However, allowing some areas to naturally regenerate could offer insights into inherent ecological processes, guiding which interventions are truly necessary.
And in terms of a forward-looking approach, how could these lessons shape global conservation policies?
We might see a shift towards policy frameworks that prioritize adaptive management. These policies would combine traditional practices with innovative monitoring technologies, ensuring ecosystems remain robust against future disruptions, much like the adaptive resilience observed post-Mount St. Helens.
The Mount St. Helens eruption also catalyzed a unique collaborative effort among scientists. Can you shed light on how international cooperation helped in the aftermath studies?
Absolutely. The eruption inspired multidisciplinary teams from across the globe, pooling resources and expertise in ways previously uncommon. For instance, joint projects with Japanese scientists experienced in volcanic activity enriched the research with cross-cultural perspectives.
However, critics might say that international collaborations often get bogged down by bureaucratic hurdles. What strategies have been effective in overcoming these challenges?
Certainly, initial efforts faced regulatory and funding barriers. Yet, by establishing clear goals and open communication channels, teams minimized inefficiencies. Joint workshops and data-sharing platforms have proven effective, setting a precedent for future collaborations.
In considering future ecological challenges, how could these collaborative models evolve?
The integration of digital technologies such as virtual reality for remote participation could further enhance global cooperation, allowing real-time feedback and enrichment of studies through a wider array of expert insights.
Beyond immediate ecological impacts, the Mount St. Helens eruption has driven environmental innovation. How can studies of such disasters contribute to sustainable solutions?
Disaster studies often reveal vulnerabilities and adaptation methods, prompting innovation. For example, lessons from soil regeneration post-eruption have informed strategies in agriculture, like using native plants to combat soil erosion efficiently.
Conversely, some point out that relying on lessons from catastrophic events might not be a sustainable method for global climate issues. How would you address such concerns?
It's a valid concern. Disasters shouldn't be the sole focus. However, they provide impactful case studies that highlight rapid change. Integrating findings from these events can inspire proactive rather than reactive environmental strategies.
Looking toward the future, how can we implement these findings to foster environmental unity and innovation globally?
Initiatives like international green hubs could disseminate disaster-derived insights across sectors, from urban planning to agriculture, encouraging innovative, shared solutions to today's pressing environmental challenges.